For today, so we're gonna leave like the first couple minutes or so just to talk about what's going on, and just let everybody join the session. Usually a lot of people tend to come in a little bit late, so I like to wait for them to join. So today we're gonna do actually that should say conservation momentum. So the first problem is conservation momentum. I forgot to change the slides. Oops. It should be updated now. So that's what we're going to be doing first is conservation of momentum. And then we're going to move on to work. And then we're going to move on to just the last 5 minutes, just any question you guys may have. So this is one of the actual VSI sessions. So like before all the classes went online, this one would have been online anyway. So this one's going to actually be recorded, and the links will be sent out before the midterm. So probably like this week or as soon as I get it. Because your guys' midterm is next week. So because of that, I didn't want to just focus on conservation and momentum. I want to go back just like in time a little bit and go back to work, because that's going to be a pretty big part of your midterm. And I want to make sure nobody forgot all that stuff because we haven't worked on that in like 3 weeks or so. So I think this would be a good time to work on that. Again, this is one of the like real VSI sessions. So this one would have been online. Even if classes were in person. So this one's going to be recorded and sent out to you guys. So yeah, it's going to be a little bit different than the other sessions that we've been doing. It's just that that one's a little bit more like interactive based. This one is just more going to be me like doing the problem, like the chat. You guys should always like respond in the chat, but it matters like a little bit less on this one. Because in the end, this one's going to be a YouTube video that you guys can like reflect on. So it's just going to be a little bit more focused on just solving the problems. I want to give a couple more minutes to anybody that wants to join because of my mistake with the link. Yeah, so I incorrectly put the wrong link. So I think a couple people are unable to join. So I'm just going to try to give them time to do that. And again, this is a great time to ask any questions you may have about the sessions or like whatever's going on in class or anything. I know you guys have a midterm coming up, so if you have any questions about what's this first one, it's a 2-part question, but we're just going to focus on the main part. So imagine that there is an asteroid that will collide with Earth unless we take dramatic action. So the asteroid has a mass of 2.1 times 10 to the 10th kilograms. And it's heading towards Earth at a speed of 12 kilometers per second. So the object is pretty huge, but it's moving relative to its size. It's moving pretty slowly. So keep that in mind when you're thinking about like how big your numbers are going to be, or like when you're doing the math. That should give you a little bit of a hint if you're on the right track or not. So our first part of the question, so it says the plan is to crash a rocket into it to stop its forward motion. So how fast would the rocket have to be going in order to stop the asteroid completely if the collision is head-on? So this is a momentum problem. So I'm going to write out our formula for momentum. So P is equal to mv. All right, we know that. We've had a lot of practice with this topic so far. We've been covering it for like, I think, even without spring break, it's been like a week and a half. So we have a lot of practice with momentum. So let's think about what our givens are. So I like to do that every time I start a problem. Just write out the givens. That's not. So our givens are, we have the mass of the asteroid. So I'm going to call that m sub a. So that's 2.10. So we're keeping in mind our sig figs times 10 to the 10th kilograms. We have the speed of the asteroid, so that's 12 kilometers per second. So I'm just gonna call that S sub A. I don't want to call it V because they don't give us a distance, so I can't really call it a velocity. So I'm gonna call that S sub A for now, just for speed. And that one is 12.0 kilometers per second. And then and then we have a mass of a rocket, which is 8 times 10 to the 24 kilograms. So looking at this one, we know this is a conservation momentum problem, and um, we're given some speed, right? So we can plug that in for v because it's the magnitude of v, because it doesn't really need the direction if we're given the magnitude. And then we have two m's. So based off this and what we know from conservation momentum, you should be able to figure out what the speed that the rocket has to go at. So I'm gonna give you guys like a couple minutes just to answer this one. So do it out on whatever piece of paper you have or whatever you're using to solve it, and then send your answers in the chat. And again, if you have any questions, feel free to ask. Just I'm always looking at the chat. So if you guys are like stuck anywhere, just go ahead and ask. But yeah, just try to solve for this one. So yeah, also keep in mind whatever units you have to use, whatever correct units have to be used for this type of problem. Again, as soon as you get a number, please send it in the chat. For anybody that just joined us, I'm sorry about sending out the wrong link. I don't know why it had an older link in there. But I think everybody who filled out the form managed to get in. But we're just working on this problem in which I guess there's there's an asteroid coming at Earth and they're trying to stop it, and so the plan is to crash a rocket into it. We're trying to figure out what the velocity of the rocket has to be in order to stop the asteroid from hitting the Earth. And again, as soon as you get your answer, please put it in the chat. Make sure we're all participating. And then as soon as I get pretty much everybody's answers, then we'll move on to solving this one. Also, again, I can't stress it enough. Please ask any questions you have at any time. I'm always looking at the chat. So if you guys need any help with anything, just put it in there. So I'll probably work on this one for like a couple more minutes. And then again, even if you don't know what the answer is, that's fine. You could just say, I don't know, or I'm stuck or something. Just let me know where you're at for this problem. But if you do manage to get an answer, please. Okay, that's fine. We're just trying to put answers in for now. So even if it's, regardless of how right you think the answer is, it's not necessarily wrong, but just send it in. But from what I'm seeing, it looks good. Okay, so we see some agreement on the problem, which is good to see. On the answers, at least. So just gonna wait for like two or three, so like two more answers, and then we'll move on to the next part, or we'll move on to actually solving it. So like maybe like 2 more minutes, and then we'll finish this one in part 8. Also, if you ever feel like you're stuck or anything, you can always look at the other answers to see maybe, that usually gives you a hint if you're on the right track or not. If you're like stuck, that might be a good idea. Just look there and then see if you think you're on the right path, just to help you out a little bit. But my clock says 15, so we're gonna go to like 16 on for this problem. Okay, so I think we're fine to move on. So pretty much almost everybody has an answer. So I feel like we can just get to solving this. So for this one, for the rocket to like completely knock the asteroid out of the way, so it doesn't like hit the Earth at all, I guess. It pretty much has to match its momentum, right? Just it has to hit it hard enough so where the resulting collision just completely pushes out of it. So it's being hit with as much momentum as it's moving with. So it kind of cancels it out, you can think. So we're gonna be using conservation momentum. Um, so we could say that m sub a for the asteroid times v sub a for the asteroid would have to equal the mass of the rocket times the velocity of the rocket. So everybody got pretty much the same answer. So it looks like you guys all set it up right. So that means we would have the mass of the asteroid, which was 2.10 times 10 to the 10th kilograms, and then multiply that by 12.0 kilometers per second. So that's a significant number. So we're gonna have to convert that into meters. But I'm just gonna leave that as that for now, just so it looks a little bit neater. And then we have the mass of the rocket, which is 8 times 24, or 8 times 10 to the 4th kilograms. My bad. And so we're solving for the velocity of the rocket. So we're just going to put VR, just rearranging some stuff. We get VR is equal to 2.10 times 10 to the 10th kilograms times 12.0 kilometers per second, all over 8 times 20 10 to the 4th. So you guys all seem to get this correct. So just plugging that into my calculator, just make sure I get the same answer as you guys. So 2.1 times 10 to the 10th times 12 kilometers, so multiplied by 1,000, 1, 2, 3, all over 8 times 10 to the 4th. Okay, so we all seem to agree on the answer. So just checking for the units. Checking for the units on this one's really important because that pretty much gives you a really big hint on whether or not you have the answer right. So I recommend doing that for pretty much every problem you can. So for this one, we can see that kilograms would cancel out. and then we'd just be left with well, you would have to convert this, but it would be meters per second. And so we can tell that our units are going to be right. So we have a good hint that our answer is going to be right. So even if the math is wrong, um, or not necessarily wrong, but like you wouldn't have to worry so much if you have the units right because you know you're on the right path. So yeah, so the answer for this one should be 3.15 times 10 to the ninth meters per second. Okay, so let's think about, all right, so we're done with that part. But if we move to part B, we can see that the speed of light is 3 times 10 to the eighth meters per second. And our answer is 3.15 times 10 to the ninth. So this is saying we would have to send our rocket at a speed that's 10 times the speed of light, pretty much, which, is impossible. So this would not work in a realistic situation. So that's what part B is all about, right? So what part B is asking, so there's an alternate plan now, and it's to deflect the asteroid's path by just a tiny bit when it's far from the Earth. So if you move something when it's far away, the more it moves, the more, like, as time moves on, it'll keep getting further because you knocked it off its path. So it says that it's going to cause the asteroid to miss the Earth by the time it would have gotten here. If the rocket is traveling perpendicular to the asteroid's path at the moment of the collision, how fast will the rocket have to be traveling to divert the asteroid's velocity vector by 1 degree? So that's a lot to read. So let's break that down right now. So we're going to call this part B. I'm just going to put a line here. So this was A, and now we're on B. So let's see what the question's saying, right? The question's saying, if the rocket is traveling perpendicular to the asteroid's path at the moment of collision, how fast will the rocket have to be going? So why don't we just draw a little diagram, right, just to help us out. So we're saying perpendicular, right? So let's call this little circle the asteroid, and it's going this way. And then they told us that the rocket is traveling perpendicular to the asteroid's path, so it's going to hit it like at a 90-degree angle. Or there's going to be 90 degrees between them. So we're going to call this the rocket. So it's moving with some velocity VR. Okay, so that's how it is initially. And so what we want this to do is to just barely knock the asteroid out so that the path shifts by 1 degree. So right now, VA is going straight. We just want it to be like this, in which this angle is 1 degree. This is what we want our resultant to look like once we're all done here. So does anybody know? So actually, not you guys don't have to answer this in the chat. So I'm gonna give you guys just a minute or two just to think about how this would change our conservation momentum formula based off what we know about it. So just take like 2 minutes, think about it, try to come up with a formula. You don't have to send it in the chat. This one might be a little tough to come up with. But just really just think about it. Think about the angle, what you would do, what you know about vectors and how you can change stuff around. Just take a minute or two to think about it, and then we'll get to solving the problem afterward. And again, if you feel like you're stuck or anything, I know you don't have to answer this question in the chat, but if you feel like you really just don't get it, send something in the chat. You can send it privately to me. Don't always remember that you can send something to me privately if you feel like you just don't want to say it out in front of everybody. So I'll be the only one who sees it. But otherwise, just take just a couple minutes to think about what you know about vectors, what you remember from doing a lot of that Newton stuff, what you could come up with here. So it's gonna take a few minutes on this one. Okay. So hopefully everybody was able to think about this one somewhat like clearly. So what we can see here, right? So we have an angle And we have our little triangle here, so we can come up with something. So the question's asking us, we just want to knock it by a whole 1 degree. Okay. So what that pretty much mean is that the x component um of the rocket has to equal the x component of the momentum of the asteroid after the collision, right? Um, that's just based off the fact that we're trying to move it just 1 degree, right? And so we have our triangle here. So if we have this as VA, we can build our momentum equation now, right? So if MV1, so I'm gonna say just M1, V1 has to equal M2, V2. Okay. So we have, and so we're trying to figure out what the speed of the rocket would have to be. So we know the mass of the rocket. So I'm just gonna start building our formula real quick. It's gonna be 8 times 10 to the 4th kilograms. Okay, and so we're trying to find the speed of the rocket, just like before. So same thing, but it's gonna be a little bit different. So yeah, and so if we can think about this triangle as the pretty much the formula for the momentum, because so it's traveling at this velocity, so we have that arrow, right? But it's also carrying that mass with it. So we can think about this triangle, right, as its momentum. And so what we know based off our triangles, so the side, so this this part right here, which is what we're looking for, right? Because we want this shifted by 1 degree. So that's what we're looking for. Excuse me. So we're looking for that, right? So based off that, based off what we know from triangles and trig and stuff, we know that this is just going to be the momentum of the rocket times sine of 1. Even though it's the x component, we can clearly see that it's going to be the sine of 1 because it's it's opposite over hypotenuse. So we know that this is going to be p times sine 1, and so p, just like from before, is pretty much the same thing. We're just plugging in mv. So we have 2.10 times 10 to the 10th kilograms times the speed of the asteroid, which was 12.0 kilometers per second. And then we're also multiplying that by sine of 1 degree. So I'm gonna let you guys do that. We'll run through the explanation one more time after you guys plug in the numbers. I always want you guys to practice plugging in the numbers just to make sure you have the formulas down and everything. So solve for VR. Again, keep in mind the units with kilometers and stuff. And just come up with an answer for VR. And then as soon as you get that, please send your answer in. Okay, so we're starting to get some answers. So again, what I recommend for like a lot of math stuff is for some reason a lot of people don't like, even if they have them, they don't like to use their graphing calculators on these kind of questions. I personally would highly recommend using your graphing calculator. I think it's a lot easier to use. You should definitely take advantage of that. I know it doesn't matter so much right now, but just for like the midterm and stuff, just keep in mind that it's gonna help you a lot more than maybe like a scientific calculator would. That's pretty much only if you have one though, so you don't have to buy one for it, but it would help a lot if you do have it. Okay, so we see some agreement on our answers, which is good to see. Okay, so we can start solving for this one. So pretty much the same things before, we're just rearranging stuff. Oops. So VR is going to be equal to 2.10 times 10 to the 10th kilograms. And then multiply that by 12.0 kilometers per second, then sine of 1 degree, and then all over 8 times 10 to the 4th kilograms. So just looking at this one, we can see whether, again, just like usual, whether our answer is going to be correct or not. So kilograms cancels out, so we're just left with kilometers per second. We're going to convert that to meters per second anyway. And then we're also going to multiply that by sine of 1. And sine of 1 is nearly 0. It's not quite 0, but it should make our answer significantly smaller, just based off what we know from the unit circle, right? We can already tell that our answer is going to make a lot more sense. So just plugging that in, we are going to get 5.5 times, so I'm going to put my answer over here, 5.5 times 10 to the 7th. So we all seem to get this one. This one makes a lot, so if we're thinking realistically, this one makes a lot more sense. That's still a pretty crazy fast speed, but it's not faster than the speed of light. It's significantly slower. So hopefully we all understand this problem. So if you guys have any questions, you can think about them and just send them in now before we move on. If you guys don't understand anything like conceptually from this one. Again, this one just to get you guys more practice in with conservation of momentum and just trying to think about what different types of problems you might have thrown at you on the exam or something. So should both answers be 1 sig fig? Well, let's look at it. So I wasn't really paying attention to the sig figs on this one. Yeah, so for this one should be 1 sig fig, yeah, because of the speed of light. So we're gonna call this, that's a good catch. This one should be 6. Don't know why my eraser is so big. 6, so this one should just be, we're just gonna call this 6. That's a good catch for the significant figures. And then the first one should be 3, I think. So we're only given 2. Actually, yeah, I guess so, because of the mass of the rocket. So that was a good catch. So these ones should only be 1 sig fig. So that one's gonna end up being just 3. Yeah, so that's good. Make sure you guys keep in mind sig fig. So I tend to forget just because a lot of the classes that I'm in really don't mind. So I always end up forgetting, but that's a good catch. That's a big deal. It's a big part of your grade, right? So that's like a whole 7. So thank you for noticing that. But if there's nothing else, we can just move on to the next part. Even if there is, you can just send me something after we've moved on. That's not that big a deal. But this one, we're going to go back in time just a little bit. And so we're going to go back to the concept of work. So I know we haven't worked with that in a long time since we've been so focused on conservation of momentum. But this one's going to be a little bit more about the whole like trying to get an answer with variables, because I feel like when you do questions with variables, it forces you to understand the concepts a lot more, because you can't like intuitively plug in numbers. So this question has no numbers in it, so it might be a little tougher to solve. So a package is dropped on a horizontal conveyor belt. The mass of the package is m, the speed of the conveyor belt is v, and the coefficient of friction between the package and the belt is mu. When the package hits the belt, it slips a little bit before continuing to rest with respect to the belt. And so the first part of our problem, so this one has A, B, C, and D, so it's a little bit of a longer one, is how long does it take the package to stop slipping on the belt? So leave your answer in terms of the variables given and G for gravity, because that's something that's like a given, right? So I'm gonna get us just started on this one, then I'm gonna let you guys finish it up. So how long does it take the package to stop sliding on the belt? Okay, so let's think about this one. It's friction that's stopping the belt from slipping, right? So so we know we're gonna have to end up using friction to find the time. And so we know friction from earlier, so this one's just part A. Friction is equal to mu times n, okay? And so that's a little bit of a hint that's just gonna get us started for now. And so when we wanna find the time it takes to stop the package from slipping, we're gonna end up using this formula. V is equal to V naught plus AT. So we're going a little bit back in time to kinematics. So this would end up being 0 because the package started from rest. And then, so V is equal to AT. And so you can always rearrange for time. So we have this F is equal to mu n, and then we have V is equal to AT. So based off this, I'm gonna have you guys finish this one up on your own, hopefully. So what I would recommend to start with is to draw a free body diagram for the package. So try to see if you can use this formula right here to get an A and then plug it in here. That might take a while. I know it's a little tough. It's not that big a deal. I'm gonna be right here. We're gonna solve it too. So I'm gonna give you guys a couple minutes just to solve this one, and then please put your answers in the chat. Again, if you guys don't know how to do it, that's fine. I'm always right here, so you can ask any questions, and then I'm gonna end up solving it with you guys anyway. So yeah, so try to figure this one out. Try to follow the hints that I give you. So try to find an A from the formula on the left and plug it into the formula on the right and solve for T. So you guys have a couple minutes to do that one. And again, I'm gonna be right here. So if you guys have any questions. So think about what forces are acting on the package if it's dropped onto a belt. Think about, are there any forces in the y direction? What forces could be in the x direction? Are there any at all? So, usually when it comes to solving those type of problems, the best thing to do is draw a free body diagram. That will pretty much answer it for you. We're gonna go for like 5 more minutes on this problem. Unless you guys start setting your answers sooner than that, which is fine. Also, I guess feel free to message each other. I don't know if you guys ever thought about that. You guys are here too. I'm sure everybody here is willing to help if you have a question. So if you guys don't feel comfortable just sending it in front of everybody, like your questions, or even sending it to me, you can always send it to each other. In the chat, you can choose it's like specifically who you send messages to. So also feel free to ask each other for help. We're all here to try to get these answers. So probably go to 38. So it's like 2 more minutes for this one, and then we'll get to solving it. And so again, the reason that we do like these problems with that are only in variable forms to just really make sure that you can manipulate these formulas easily, and also gives you a less clear understanding. Like you can't look at the units like you usually do as easily. So it's gonna really challenge you guys to understand the concepts of what's going on. So maybe like a minute or so, and we'll start figuring this one out. Okay, so let's start solving this one. So, like I told you guys, so I'm gonna start off with a free body diagram. So when the package is on the belt, let me move this down a little bit. So when the package is on the belt, there's a force of mg, and then there's the normal force. So we know friction is equal to oh, well, there's also, yeah, well, there's also the friction force. So that's what's stopping the thing from moving. So if we know F is equal to mu times N, and then from this diagram, the box is not moving in the y direction, so we know N is equal to mg. So we can just plug that in here. So mu is equal to mg. And then so in the x direction, the only thing acting on the box to make it stop moving was friction. So we know that the force due to friction is equal to ma, because the total force is just friction. So so friction would be equal to ma here. And so we know friction is equal to mu times mg, which is equal to ma. And then we can just cancel out the m's, and then we can solve for a, or it's already solved for us, I guess, which is equal to mu g. And so now we have an acceleration from the box, and so we can just plug that into our kinematic formula. So v is equal now to mu gt. So then it's asking us how long did it take the package to stop slipping. So t would be equal to v over mu g. So hopefully we'll all see how this one works and why it works. So if what caused it to stop slipping was friction, based off the acceleration that we get from friction, we can just solve for time using our kinematic formulas. I know it's a little bit different than our usual questions, but it really gives you an idea about how you can connect a lot of concepts. And so we're gonna move on to our next problem, which is B. So B is, what is the package's displacement during this time? So it's pretty much just asking how much did it travel in, I guess, the x direction. So it didn't really, so we can just tell that it didn't move in the y direction. It's on a conveyor belt. It's only going to move in the x direction. So this one's going to be really similar to the last one. So based off the values we got from the last one, we should be able to solve for this. So we're going to end up using our formula here. X is equal to x naught plus v naught t plus 1/2 at squared. So you guys should be able to solve this one using all the values we have. So we have our t here, we have our a here. So I'm gonna give you guys like 2, maybe 3 minutes just to solve this one, and then we'll get to solving it ourselves. So based off what we know from the problem initially, and then the things that we've solved for, we're gonna finish this one. And this one, please send an answer in the chat so I can tell where we're at, if you can figure this one out. And then I know it might be a little bit hard to, so for mu, if you're gonna type, so if you're gonna end up, if your answer is gonna end up having mu for this one, I would recommend just type an M instead of the weird Greek letter, or just type a U. Actually, yeah, just type a U. No, I did not think of that. So yeah, so if you're gonna, if your answer is gonna involve mu, just type a U. Okay, so we're starting to get some answers in. Okay, so we seem to have some agreement on our answers, which is always good to see. You're on the right path. Okay, so we're gonna work for like 2 more minutes on this one, or just until everybody has an answer sent in, whichever one comes first. Okay, so we pretty much all seem to be agreeing on this one. Okay, so I think we're good to start solving now. So you guys all seem to realize what to do on this one pretty easily. The x naught is 0, started at position 0. We determined earlier that v naught was 0, so we can get rid of that. So x is just going to equal to 1/2 at squared. We know a is equal to mu g, so x is equal to mu times g. And then square, so it's going to be v squared over mu g for t. So square that. And then over 2. And so, actually, that's not, I'm just going to 1. Here we go. This looks a lot better than before. So these are going to end up being squared. So, actually, this should not be squared. These are going to end up being squared, so we can cancel out one of these with one of the squares that would have been here. So this is going to equal 1/2 v, or just v squared over 2 mu g. So that's how we get the answer for this one. So good work. You guys all seem to understand this one, which is good to see. And so our next one is how much work, let me scroll up so you guys can see. How much work is done by friction, and is it positive or negative? I'm gonna let you guys do this entire one on your own. So I'm not gonna give you the formula to use. And so hopefully you guys can figure it out. So I'll give you guys like 5 minutes for this one. To try to figure out. And then again, same as last time, please send in your answer to the chat as soon as you can. And I'm right here for any questions. So just think about the different formulas that you know for work and then try to figure it out. And if you guys just need help getting started or anything, or like you can't figure out what formula to use, please let me know. I can help you guys out if you guys really need it. But then just try your best to figure out what to do. Okay, so we have some answers. Okay, so we're gonna work on this one for like 3 more minutes or so. And then we'll get to solving it. So C and D, so the answer to C will pretty much give you the answer to D. So this is kind of both of them at the same time. Yeah, so we're pretty much answering C and D here. It's Probably gonna go for like 2 more minutes on this one and then start solving. And again, still feel free to ask any questions. That's why we're here, is to ask questions that we may have for class. So and again, this is going to be one of the SI sessions that's going to be uploaded onto YouTube. So hopefully, as soon as I get the link, I actually just got a lot of links to the last couple of VSI sessions. So I'll probably be sending those out at some point before the midterm, so you guys can use those to study. There's a lot of good questions in there. So even if you don't want to watch the full YouTube video, you can just take the questions and use them as practice because the answers are going to be there too. So I recommend looking at those when you have the chance. We're gonna go for like 1 more minute on this one, and then we're gonna start working on it. Even if you guys don't get the answers, as long as you're practicing different methods, that's what we're looking for here. Okay, so I'm gonna get started. Okay, so for this one, so based off we know from work, so one of the main formulas that we used for work was work is equal to F dot D, which like these are both vectors, right? And so what does the dot product mean? Well, the dot product is the same thing as the two vectors that you're dotting together. You multiply them, and then you multiply them by the cosine of the angle between them. So let's think about this one, right? So we figured out the force earlier, right? So we figured out the force was equal to UMG. That was the force acting on the box in the x direction, which is all we care about now, right? So I'm just going to write that on the side in a different color. F is equal to mu mg. Okay, so we have one thing, and then we have the distance. Well, we just figured out the distance. The distance is pretty much x. So the d in this part is going to be equal to v squared over 2 mu g. Okay. Yeah, that's fine. Good job, though. So now we just adopt these together. So we're just going to start off by multiplying them. So mu mg times v squared over 2 mg. Okay, but we can't stop here, right? So let's think about how that cosine is going to affect this answer, right? So if we look at our free body diagram from earlier, so the friction, so that's really our force, right? The friction force is what our F is here, right? It's going towards the left, but the displacement of the box is going towards the right. And so if the cosine of the angle, if the angle is the angle between them right here, right, that's going to be 180 degrees. So the force is acting on it this way, but the box is moving this way. So when you dot them together, you have to plug in 180 degrees for cosine. That changes your answer significantly, right? Because cosine of 180 is -1. So it's not going to change the magnitude, but it is going to change the sign. So once we finish this all up and start canceling stuff, I plugged in mg. I'm sorry. So this one should be mu g right here. So this mu is going to cancel out with this one. This g is going to cancel out with this one. So we're going to end up with v squared. So pretty much we're going to end up with 1/2 mv squared times cosine of 180. So I'm sure you guys recognize this formula. That's the formula for kinetic energy. That just happened to be this way. So yeah, that was just a coincidence. But we can't forget about the cosine 180, so that's going to make this answer negative. So we're going to end up with negative 1/2 mv squared, and that's our answer for C. And then D is just asking, is the total work done by the package? What is the total work done by the package? Well, it's the same thing as C, pretty much. What C was supposed to do was just give you this value right here, um, this part, and then D was supposed to pretty much ask if it's positive or negative. I just decided to do that in the same thing. So that's our answers for C and D, pretty much. So hopefully we all understand why the answer is negative. Again, let me just re-explain it. The force acting on the box was going this way. The displacement of the box was going this way. The angle between them is 180 degrees. That's how dot product works. I know you guys might not have too much familiarity with dot product before this class. That's a lot of like Calc 3 stuff, so that's still kind of far away if you're not taking that class right now. But yeah, that's how that one works. So that's how we calculate work for this problem. So hopefully this one with all the variables and stuff, it gave you a really good look on how to manipulate stuff, how to try to think about things like that, like the angle between two things that you're dotting, or trying to plug in stuff for friction and trying to figure out what that's equal to, stuff like that. So are there any questions on this one, or anyone's a little confused on anything? Or they feel like they're stuck, this is a great time to ask now.